Alrighty, y'all. This video should be much quicker than the last one because I don't have any calculator steps to do, and I want to go home for the weekend. So, yeah, let's get cracking. Okay, so 6.5. This is our last unit or last section for Chapter 6. It's on two-way frequency tables. So it's your Common Core Standard is SID 5, which says summarize categorical data for two categories into a two-way frequency table, interpret relative frequencies, and recognize possible associations and trends in the data. So lots of vocab here. So we're going to talk about all of these things, what categorical data is, what a joint, relative, and marginal frequencies are, and marginal relative frequency, two-way relative frequency tables, conditional relative frequency tables, lots and lots of frequency stuff. Two-way frequency table, marginal frequency, joint relative frequency, lots of frequency. Okay, so looking at this table here, it says it shows the number of boys and girls at Aubrey's school that own and do not own bicycles. Based upon the table's data, Aubrey concluded that the girls are more likely to own a bicycle than boys. Is this a valid conclusion? Explain. So, if you look at this table, 16 boys own bicycles and 18 girls own bicycles. She's saying that the girls are more likely, probably because she's just looking at that number. 18 is bigger than 16. However, if you look at the amount that do not have bicycles, it's 4 and 12. So lots of more girls don't own bicycles than boys. So I would say her conclusion is probably not valid, because if we were to look at percentages, the percentage of boys owning a bicycle is probably going to be higher. But we'll talk about what how we can interpret data like this in this lesson. Okay, so that was what we call a two-way frequency table. And we use this to draw conclusions about categorical data. Categorical data are data that fall into categories, such as boy or girl. Two-way frequency table is a table that corresponds to the frequencies of two different variables. So, for example, the boys and girls, the gender, was one category, and then the bicycle status was the other category, so either they own a bicycle or do not. And so we're comparing those. There's still two variables, and we're comparing those two categorical variables in this table. It says two-way frequency tables have at least 2 rows and 2 columns. An entry in the body of the table is a joint frequency, meaning any of these 4 here in the body are going to be joint frequencies, because you're comparing your two variables here. So boys and bicycles, or girls and bicycles status, etc. Okay. Any entry in the total rows is called a marginal frequency. So all of these here are marginal frequencies. And then you have your grand total here. Okay. So these ones are marginal frequencies because they're in the total section. The rest is just called a joint frequency. Okay, on we go. Okay, so we want to make a two-way frequency table now. So on Saturday, 201 tickets were sold for 2 movies, movie A and movie B. Oh, how original. Can't wait to go see movie A this weekend. Okay, so I'm going to start with my 2 categories, movie A, movie B, and you also have to have room for a total, so we'll do that. Okay, of the 103 tickets sold for movie A, 78 were sold to men. Put the men here. And then 86 were sold to women, so women down here. And then again, we need room for a total. So here is our setup. Voila. Now we just got to fill in some numbers. Okay, so let's look at the numbers it gives us. It says, of the 103 movie tickets sold for A, so that's telling us that there's a total of 103 for movie A. So I'm looking at movie A here. My total is going to go down to the bottom here, and that's going to be 103. It says 78 of those were sold to men, though. So 78 of this 103 here, so I'm still in this column, were sold to men. So this should be 78 right here. Through that arrow. So that should be 78. So 78 of the 103 were sold to men. That means we could figure out how many are sold to women, because if I add up this total here, it should give us 103. So 103 minus 78 gives us 25, I think. Yeah. That means 25 were sold to women. Okay, so we've got the first column done. Then it says of the 98 sold for movie B, so again, 98 down here, 86 were sold to women, so 86. And then that leaves 12 remaining up here to total up the 98. Okay, and then we just need our totals in the rows. So we can just add up horizontally. 78 plus 12 gives us 90. This one is going to give us 86 plus 25 is 111. And then your total, so your grand total down here, you can actually get that from either adding up the columns or adding up the row totals. So, and you should get the same thing either way. 90 plus 111 is 201. And I should get the same thing if I do 103 plus 98. And that is 201. So that's a good indication that we've done our table correctly. Okay, so that's what your 2/8 frequency table should look like. You don't really need all these pluses and equal signs here, but yeah, it should look like that. Again, these are joint frequencies here. These in the boxes are marginal frequencies because they correspond to the totals. Okay, next. Okay, so go ahead and try this one. It's talking about freshmen and sophomores in math and English classes. So those are going to be your two variables. You go ahead and try to make this table. I will make it, and then we can see how we did. Ready, break. Pause this in 3, 2, 1, pause. Alright, I didn't quite finish this, but I just wanted to stop and show you where your total should be going. So it says a survey asked 170 freshmen and sophomores. Okay, so that's actually going to go in your grand total. Okay, because it's freshmen and sophomores combined. So that should be grand total 170. Of the 87 freshmen, so 87 goes in the total freshmen, 36 said they prefer math, so 36 up here in freshman math. Of the 83 sophomores, so total of 83 on the sophomores, 27 said they prefer English, so sophomore English, down here 27. Now we can figure the rest of things out. So 87 subtract 36 will give us this guy right here, the English freshman. That would be 51. And 83 minus 27 will give us the sophomore math. So 83 minus 27 is what? Good question, 56. So, I mean, sophomore math must be more enjoyable than freshman math, if you have anything to look forward to. Okay, and then your totals, again, you just add up the column or the row totals. So 36 plus 56 is 92. 27 plus 51 is 78. And if we added those, we should get 170, which we did. Yippee, we're completed the table. Okay, next. Okay, we move on to relative frequency. Relative frequency, such as girls who own a bicycle, is the ratio of the frequency of the category to the total frequency. Okay, so it's basically just the percentage expressed as a decimal of each category. So, for example, you can find a joint relative frequency by dividing the frequency by the total column, frequency by the grand total. Okay, so here we had 16 boys that owned a bicycle. We can divide that by the grand total of 50, and that gives us 0.32. 4 divided by 50 gives us 0.08. 18 divided by 50 gives us 0.36, and then 0.24. So those are all joint relative frequencies because they're within the table, in the body of the table, and we divide it by the total, grand total. And then your marginal relative frequency will be dividing the total by the grand total. So this is a marginal relative frequency, 20 divided by 50. Again, your 50 was your grand total. 30 divided by 50 gives you 0.6. This one is also marginal, and that one's marginal. Notice that your grand total should always be 1 because you're dividing it by itself. So all of these, 0.6 plus 0.4, that should add to 1. These two should add to 1. And if you added up all of the joint relative frequencies all on the inside, that should also add to 1. So like this, plus this, plus this, plus this. If we added all those up, that should give you 1. Okay, a two-way relative frequency table displays both joint and relative and marginal frequencies. Relative frequencies. So basically it's the same as a frequency table. You're just dividing everything by the total. Okay, so use the data from problem 1. Okay, let me hurry and copy that down. Uno momento. Okay, so this is what our table was originally. If we want to change this from a frequency table to a relative frequency table, we just divide each of these numbers by the total, the grand total, which is 2. Great. I was just talking a lot there. I don't know what you heard, what you didn't, because I paused it on accident. Sorry. That hasn't happened for a while, though. So you gotta give me some credit there. Alright, anyway, so it says, what is the joint relative frequency for men who saw movie A? So you're just looking at that section, and it ended up being 78 out of 201. I changed it to a decimal, it's 0.338 or 388. Marginal frequency for women is the total. Marginal means total. Hello. Okay, it keeps stopping. Anyway, here's your answers to this. We're going to move on to the next slide. Okay, now we're going to talk about conditional relative frequency. You get this by dividing the joint frequency by the marginal frequency, basically. So the joint frequency by that row's total or the column total. Okay, so we've got this. Actually, this one's not quite finished because we're missing some totals here in this section, so we better calculate those first before we continue. Okay, so our totals, you're just adding up the columns on this one, so you're adding down. 79 plus 19 is 98. 57 plus 45 is 102. And then 33 plus 68 would be 201. Okay, and then we add up the rows this way. 79, that's a lot. Okay, hold on, I need a calculator. 79 plus 57 plus 33 gives us 169. And 19 plus 45 plus 68 gives us 132. And then our total should be 132 plus 169, 301. What happened here? This one wasn't right. Why did I put 201? I was adding the wrong things. Okay, so this one is not 201. This one is 101, I think. 68 plus 33. Yeah, 101. So do those add up to 301? Yes, they do. Okay. Now we can finish the problem. So it says, A, what is the conditional relative frequency that a person surveyed supports the bond issue? So he supports the bond issue, given that the person is between 18 and 25. So this given part, this is telling you it's a conditional relative frequency. So if you're given, you know that that person is between 18 and 25, we only need to look at that column. So you can ignore the rest of this stuff over here. We're given that they are between 18 and 25. I'm going to undo that because we're going to use that in a minute. But we know it's in that highlighted column. So if we want to know if they support the bond, that's 79 out of the total, which is 98 of that column. So this one you're taking the 79 and you're dividing it by the column total. This is a conditional relative frequency. So 79 divided by 98, 0.806. Hello, work, 0.806. Okay, next, what is the conditional relative frequency that a person surveyed supports the bond issue? Given, again, given, that's interesting, that the person is between, oh shoot, what's happening? Given the person is between 26 and 64. So now we're looking at the second column here. So we know they're between 26 and 64. We want to know if they support it. So 57 out of 102. And if we divide those, we get a number, 57 divided by 102, 0.559 if we round it. Okay, and then the last one was the conditional relative frequency that a person surveyed supports the bond issue given they are 65 or older. So now we're looking at our last column, 65 or older. So supporting would be 33 out of 101, which is 33 divided by 101, 0.327 approximately. Okay, and that is conditional relative frequency. So you're just taking your number and dividing it by either the row total or the column total, whatever it gives you, whatever the given is. Okay. D, what can you draw based on the conclusions? Well, I would say that the older you get, the older the sample is, the older the people you are that survey, the least likely they are to support this bond of the expansion of a public library. It seems kind of backwards to me because older people should like libraries because I feel like most older people have used libraries more than young people. Okay, this says use the table in problem 3. And what is the conditional relative frequency? So conditional relative frequency, we just did that. Oh, okay. So yeah, now it's just doing the opposed. So basically you would say you oppose divided by whatever your total was here. I don't think we need to go through and do all that because it's always just going to be the opposite. Okay, but that is conditional relative frequency. So those are all relative frequency tables and how they work. Yeah, and that is all I have for today. So I hope you're all enjoying your weekend, and I will now go enjoy my weekend. I will see you all later. Au revoir.